Okay, so for today I thought, well, it's been quite a long time since we did anything with a cool compiler, so wouldn't be a really interesting idea to try and implement a compiler in our own language for our own language, right? So to make some kind of self-hosted language. And I mean, this would be pretty difficult to do, honestly, so maybe we can start with something really simple, like making a really small lexer for a subset of the language, and we'll see from there. Maybe, at some point either we can finish it, or I mean, it's still gonna be a good first step for anyone who wants to implement a compiler. And it will also show you that it doesn't really matter which language you use, because I mean, we can take a look at this language. It's pretty scuffed. It looks a bit like Java, so I mean, I guess you think, oh, maybe it's a bit useful, but yeah. But I mean, the array is pretty scuffed, so probably not gonna use it. And then we have a linked list, which sure, we might use it, so linked list might be the way to go, actually. So module data, that's how we import stuff, basically. So we don't have the import keyword, we import the files at compile time, which is, I mean, I don't know. Yeah, and we also had this multiplayer game, so I mean, pretty cool language, let's say. Okay, let me just take the hello world file. Like this. So if we make examples and we build the compiler, it should say hello world. Perfect. Now, yeah, the only issue is that we cannot take in command line arguments. I'm not, honestly, I don't think I'm gonna do that. It's, we would have to go back to assembly and stuff, so not really fond of that. So let's say that this compiler only takes in as input from stdin, basically. So let's say that's the case. Maybe it makes sense to have that. So if I remember correctly, it should be something like text, let's call it, right? Text is gonna be a string, and it should be initialized with io.in string. But I mean, there's also inside of prelude I mean, in string, I think it reads until new line though, so that's also something. Okay, I mean, yeah, whatever. Linux.cl, and I mean, read, I think even in Linux syscall, I think read, doesn't it read until new line as well? So you give it a file descriptor, a buffer, and how much to read, and it returns you how much it read. So yeah, I mean, I think it reads this much, so at at most. So yeah, whatever. Let's use int string for our purposes. So int string is gonna be just this, and let's do in, and let's do like, let's print the text. Okay, so line 329, I guess in new IO. And let's say we are going to do something like this, right? And try to parse it. Now sure, it's going to be interesting to read an entire file, but or I guess, you know, read the entire buffer. So I'm just thinking if it's possible to do that. Because I mean, this one is basically while you read 1024, you keep reading. Right, so yeah, I guess let's try to cat examples compiler into, okay, so I guess we can just do this thing and it's gonna do the entire file. So this also works. Okay, perfect. So okay, what would be next, you know, from the past experience is to actually tokenize the text. So let's do class Tokenizer. Okay, so what should this return? I would say it's a linked list of tokens. So it's gonna be a list, and let's say of token. Right now I'm not sure what. So it's just gonna be, you know, single init append init. Not that crazy. But we need this token type, right? So, and I think I want to do it like this. Class token is gonna be like a class, and then we are gonna have class, for example, token int, which inherits from token. And the cool thing about this language is that we have this case. Wait, I don't remember how to use it. Yeah, it's case, right? So we have this case of, so it's gonna be case and then token of, and then we can use, no, if it's token int, I guess int is token int, then we do something. So this is how we are gonna handle that, right? So, and in this one you can say int.value, but I mean it's gonna be like this. So for example, I mean, I guess all the tokens should, I guess all the tokens should have a value string, line int, column int, I guess cal, position. I'd say position is just like the real position in the character array, right? So I would say that all the tokens should look like this. And yeah, we'll also need to make the functions that do all of that. So sure, would they require a constructor in this one? So like in it I was just thinking, should we pass in value, right? So we pass in the value, but should we pass in pause and just that, or should we also pass in the line and the column? I was thinking to compute the line and the column from pause, so but that would mean we need the text here. Don't think I want that. I think I want to pass in line, column, and let's say this thing returns a token. But you know, might be easier to just pass in the buffer here. Honestly, I think it's gonna be easier. So and these should be like V and P because we cannot have the same name. So V is gonna, value is gonna be V, pause is gonna be P, and this needs to be a block because it's a lot more stuff in here. Okay. I'll have to see how to deal with buffer because I think we have to split it by lines and then, you know, compute the line and the column that way. But for now, let's just keep it like this. So let's add a couple more tokens, like simple tokens. For example, plus. And I mean, let's leave it like this for now. So the tokenizer should probably have an init with text, right? And it should return back a tokenizer, or I guess it should return self-type. It's better that way. Right, and as usual, if you remember from the actual Tokenizer lexer.c, or I guess lexer.h file. Actually, it was in lexer.c. I guess the lexer is just the string, the lexer position, read position, and the character. So I guess, you know, we could add these as well in our lexer. So we have the buffer, it's gonna be string, position int, this read position is gonna be int, and ch. Do we want to have ch? The question is, do we want it to be a byte? But yeah, whatever. So buffer would be equal to text. And I mean, funnily enough, we can just look at how I did it here. Right, I'm curious about lexer init, right? So lexer init initializes everything with zeros, and then we were doing a read char. And yeah, this part I saw it done like this in that right, interpreter book or whatever, but it's like only the structure of this lexer, not, I mean, the rest I did it myself from, I don't know, past experience with trying to build languages, seeing what works and what doesn't. So I guess that's the best way to approach things, do them, fail it, and then do it again. Like, there's no point in reading a book and not doing the thing, actually. Like, you just wasted time. So where is, okay, so let's see. But yeah, like, this approach, I really liked it, so that's why I did it like this. I thought, well, it seems to work, and why not? So yeah, let's do these things. These functions: lexer pick character, lexer read character, you know. So let's do pick char, and this method is just gonna return the character at the read position, so it should return a byte. So yeah, curious, like, this one is -1. Okay, whatever. So I guess we can do the same thing, like if the read position read pos is greater or equal than buffer.length, if I remember correctly, then we return new byte from int 0 or something. Alright, I guess we don't have return, what the fuck. Okay, and otherwise, so on the else case, oh, and we don't even have this. Okay, I have to then else and phi, so I have to remember how to do these things. Right, on the else case, new byte from string, and here we have to pass buffer. Let me check with prelude. Actually, let's do something like this. So we have compiler here, prelude.cl is gonna be on the second one, so you can just swap between them. Yeah. So So string, right? Yeah, it has a length function. Oh, but I was curious more about substring maybe. So substring substring I should maybe add a at like add function in here. You know what? It's finally enough. We can actually just do that, like modify the standard library when we want. So it's gonna be at, we give it the index, and this thing, I guess it can return a byte. Why not? Okay, so it can return a single byte. So what it has to do is well, I guess it's enough to just do new byte from string and then subster I1. Right, so that's at for you. Yeah, basically. So in here I can just say buffer at, and I think it was read pause, and this thing just returns a byte. So buffer at is just what we need. Okay, and we can put this one on 3. So okay, for the next one, this one is read character. So let's do read char. Again, I think we should return a byte. Okay, and here what we do is read a character, and then we advance the lexer. So we could say that we are gonna have a block this time for real. So ch, which is our character, is gonna be picture. At the end we return character, and in here we are gonna do this stuff. Right, so we are gonna say that position is equal to read position, and then read pause +1, so we advance it. This is basically the translated C code into cool. Okay, and if you remember from the initializer, we have to read char first step. So yeah, so I think that's all for like the base. Now we should get into Tokenizer, but first let's see if it's gonna work. So we should do something like new Tokenizer dot init text. So this is gonna create a tokenizer. So I made a oopsie doopsie in prelude. Oh yeah, I forgot about that. We have to put semicolon after almost everything. Oh my god. Yeah, that was the annoying feature of the language. The spam of semicolons. Anyway, I think this should make it happy. Didn't. Line 15. Oh, inherits. Was it inherits or something else? Line 33. Okay, so the comparisons in cool need to be the other way around. Only this one works. So line 52. Oh, it wants something, so let's do new list. Yeah, I think I want to go into the make file actually. I think I want to have it as separate thing, make compile. So line 8, right? Oh, self. Okay, it just compiled. So let's see. Oh, I mean, I want the one with cat. So it didn't crash. That's a good sign. Okay, so it didn't crash. That's pretty good. So now for the tokenizer, I guess. Let's see how I did it in here. I guess next token would be the function actually. That's more important. So next token, and this function basically advances the lexer one step, one token. So let's have it like this. So it returns a token, and we can have different, like more tokens in here. For example, class end, I guess token end inherits token. We could also have class token invalid inherits token, and then we have our other tokens or something, right? So that way we can do some easier things. Okay, so next thing that I want to do is this skip white space. It's really useful, in my opinion. I think it's good. So let's implement skip white spaces, and I think this one returns void, but we don't have void, so let's say object. I mean, it can return self-type, but it doesn't matter, so it's just gonna return object. So yeah, skip white spaces. Let's see. I think it was really small, so oh, but I need this is space. Well, we can add it. So while ch.is space, right? Who said we cannot do this function on the byte? I mean, we can. So while is ch is space, we have to read char. And I guess in these languages while, and then we loop, and then we pull. So yeah, if we compare it, it's basically the same thing, but we need this is space function. So let's go here and yeah, let's do the is space. Should return a boolean. So yeah, sadly we have to use maybe we can use toString and compare it that way. So let character is going to be equal, so it's going to be a string and it's going to be equal to toString basically. And then we need an in. Let's not forget about this. We need an in, and the in is gonna do something like, well, I'd like to see. Okay, I cannot see, so we can do something like c is equal to space, or c is equal to new lines. If you use any other white space, then it's your problem. So I'm just kidding, but yeah, let's keep it simple like that. So it is what it is. And then we need to have a really big if. But we could also do token. I think I was calling it illegal, so let's do illegal also, just to make it compiled, right? So okay, now that we need to make it first. So on line 59, exactly. So on line 60 we have an issue. Okay, so it needs these extra brackets for the block. Okay, it compiled. I'd like to do it in one go actually, because yeah, so you know, it didn't crash. But I mean, maybe anyway, let's keep going until we have something that, you know, gives us a result. Okay, so if we take a look at this thing, well, I guess it was next token. We are gonna need to check for stuff. So yeah, as I said, let's say that we started with the simple stuff like plus. Right, so we could do something like if the character is equal to plus, but I guess I guess the other funny thing that we can do is have something like plus is gonna be byte, but it should be a new byte from string plus, right? And now we can compare it with plus. Okay, new token plus. And sure, we have the position, so we can keep that, I guess. We can keep that. We also have to read char. So let's do let position is an int and it's equal to pos in. Alright, that's how we have to do it. Okay. Then here we need to read char, go to the next character basically, and then we return token plus. For illegal is the same thing. I would say we need to read char. And I guess the question is, why not do this thing in the front of the if? But that's mainly because of these cases where we have multiple things. So yeah. But in in the plus case, I think we can put the position. So we have the init for the token, which gets in string, p, and buffer. So it gets in the value, the position, and the buffer. Well, I mean, this one doesn't really matter. I could also make something like like the tokens. I don't think they had well, they had line and column, not gonna lie. So but that's more like computed here, so yeah. But I can make something like with value, right, with value, and this is gonna be value is equal to v and then self with position p okay, and we have pos is equal to p and then self, and no longer init. we'll see with line and yeah, and I guess we'll see with the line and the column. I think it's gonna be separate. So yeah. So this can be with position, and I give it position. Okay, and token illegal can be with value to string, with position, yeah. I think that's good. Okay. And I guess in Tokenize we just have to do this while loop. But it's also like for next. Oh, I guess yeah. When character is 0, we stop. So let's call it EOF. It's gonna be new byte from int 0. Right? So yeah. I guess here I can just say EOF to make it more obvious what we return. So yeah, here is gonna be if and the list of fees is coming. So interesting, I did read chat again. So read char token end. I don't care about anything basically. Token end is just token end. Okay. So now I guess it's gonna be more interesting. But we can just, you know, use a append on it, so that's the way to do it. So as I said, I think we can take a look at this implementation. So not sure if I actually needed a do while though. Maybe I did because of this. So let's try to get a token. So I guess let result is gonna be a new list, right? So we have the new list, then we need token. I'd say it's gonna be next token, just like that. And then we can have in, and here it's gonna be the while loop. So while, ooh, while token type is not end, yeah. we can have a case in here. While case token off, and if we have like t is token end, then true, and if t is token, like any other token, is false. They suck. Think something like this, and in here we can say next token, but it's gonna be again like block because of the while. Yeah, so yeah, because of the while it's a block. So the next thing is to append the token to the list. Oh, I guess these two can go the other way around. It's gonna be new list single token, right, like that. So we next token it, and then we append it, then we append the token. So result append token. Me pressing GD here. Okay, so append basically appends an object, right? So yeah, I think this should tokenize. I mean, probably not gonna compile, so let's see. These functions needed a semicolon. Fair enough. 28. What? Wait, what? Oh, I remember. These are like variables should start with lowercase or some bullshit like that, so let's do like b, like byte. Okay, whatever. Holy shit, it compiled. Okay. So how about doing a printing of the... Oh, but I did only init. Yeah, fair enough. So let's also do tokens is a list of token. Right. Tokenize. Let's print something. Sure. I'm curious in data list, what can we do here? So, well, we have value and next, so that's good. So how are we gonna iterate the list, right? So that's a good question. I think we need to have like a iter. I think it was like this. Yeah, while not is void. But I mean, while not is void is a good thing to copy. Think here. So do some stuff and then iter next. io.outString token. Let's see what happens. Only one token? That's interesting. So case iter value of, and we have the token, do something like this, and object is gonna be, I don't know, like port or something. So we have a token. Now the question is, what token is it? So okay, let me try to do it like this. Oh my god. The fuck, VT? Yeah. I was pressing something else. Illegal plus int. So I'm curious to see what token it is. Illegal. Which makes sense because it's C in here. But let's do a separate file. Test.cl, and let's do plus. Maybe multiple pluses and then some digits. So we get at least one, but I wonder why does it stop. Oh. While this should be false, this should be true, I think. Okay, and it actually stopped working for some reason. Okay, let's see the position. New io.out int position, or I guess pose doesn't matter. Let's also do a new line because that was a flashbang basically. Okay, so the position increases way beyond the thing. I'm curious what the buffer length is. What the buffer length is, it's 6. So at some point it should return EOF. So ch to int, let's see the character, so it starts to be 0, right? So then shouldn't it just do token end? Nice debugger, bro. Oh, I mean a debugger. Okay, so it gets here, right? So it does token end. That's good. So then I guess we can do this. Oh, I'm so... Yeah, so actually, I mean, it worked. I just forgot to update the token. So yeah. So let's put here out string. Let's put a new line or something. New line between our tokens, and if we take a look again, plus plus plus, then illegal because we don't do anything with the numbers right now. Let me test CL it. Let's put some spaces as well. It still works. Still fucking works. That's great news. Okay, let's take a look again at this one. So here I have token type to string. Let's do to string. I guess, you know what would be interesting? I have this to string on object. Okay, which is pretty cool. Or I guess type name, but we can overwrite to string. That'd be cool. So we can say something like this is to string, returns string, and it's gonna be abort and an empty string, just so that we are forced to implement it. Let's say it's like an abstract method. So For example, this one, token end. I think it's like, where is end? Huh. And I mean end is end, right? Okay, so I would think, and yeah, so this is gonna be the function that we need. I guess illegal, is it illegal? Yeah. Then for plus, I think it's plus. And for int, it's int literal. I just want to have the same naming as this one. So then it's even better because we can just t.toString, right? And we get exactly what we thought we would get. Now sure, it's just a matter of adding all the other tokens, but I think it's gonna be more interesting to also see how we can implement this function further. So yeah, let's see. I guess we can also put this one here just so we have it there. Okay, so that's the basic lexer, let's say, most basic one. I think I also want though to show the int. Or I guess to parse the integer, so we'll see. Okay. Position to LC, I mean that's gonna happen at some point. But not right now, so here's what it is. Let's go into tests, lexer. Okay, so it puts some stuff. Okay, fair enough. Yeah, I don't know if I want to go to the same steps or just try to make something really simple first. So that's also a thing. But yeah, let's try to maybe like just do integer for now. I don't remember how I printed this thing though. That was interesting. So it's like just return the tokens. Yeah, I don't remember. Maybe it's in display. Oh, it was something like if it has a literal, then print the literal or something. Yeah. Whatever. but yeah, maybe something like that. It was yeah, something like that. Anyway, so let's see. Let's see how I was getting the integer then. Where is the int? I mean, it was like is digit. So I guess we need a separate thing for each digit. That's it. So in byte is digit. We have to do the same thing, sadly. It's gonna be 0, 1. You know, I mean, I'm not even gonna think about it. I could do the one with less than or something like that, but should I mean, why not? So it's gonna be 0 is a bar, it's an int, I guess. So it should be new byte from string 0 to int and 9. New byte from string 9 to int, and then C is gonna be an int, basically to int. Right. So now if I say smaller or equal than C, or C is smaller or equal than 9, that's its digit. So I can add another one now, else if ch is digit, then let's do it like this for now. So it should see, what the fuck? Okay, so it started to spaz out. So we get 3 int literals, but we should get only 1. Right, we should get only 1. So yeah, we should make a while loop. That's the only thing. We should just make a while loop. So we basically have the position of the start, right? We have the position of the start, and we need to figure out which is the position of the end. So that's it. And we can do that while ch is digit loop pull, and we need to just do read char in this one, I think. yeah, we can just read char. So like we should only see one integer now. We don't. Okay, doesn't work. Okay, why doesn't it work? Char. Curious. Oh, because I said or. It has to be and. Yeah, so we get a single int literal. Now we could as well put here with value, and for the value we can put, so you can say something like let L, which is the length of the token, is gonna be pos minus position, or I guess v value directly. We can say it's gonna be a string and it's buffer dot subster position, and this is the length. I think that's the length. Position minus position, yeah. With value v. So I think that's it. Okay. And I said that we might need here a value function. That returns value. I was thinking of doing like optional for a string, but might as well just, I don't know. Whatever. So here it's like this, so well, I mean, let's do it like this. So we put that string then if t dot value is, I guess, not equal to that, then new io dot out string t dot value Yeah. Else we don't do anything. Line 15. Okay, yeah, this one. Okay, so we actually get something. Actually made small part of the lexer in this language. That's pretty cool. Yeah, so I was just thinking of adding the optional type, which I think is more of a data structure. So we could do that just for the memes. So data optional. So it's gonna be optional, and that's the class. And then we can have class none, which inherits optional, and class some, which inherits optional. And this one needs a value, which is object. But see, it's like, meh. You have to do too many cases. And those cases make it like hard to use. But I mean, could be worth to have. So init v object returns self type. Okay, v is equal to v and self, and we also need value, which returns object. Right, so it's something like this. So now we could say here this is optional and it's of type string, right? And with the value we could say, oh, and by default it could be none, right? And here we could do some. Almost started to write Rust. Some init v. Okay, and value should be optional, again string. Right, so this one should work like this. So by default it's gonna be none. Right, and now let's follow the errors. So line 2, new none. On line 3, wait, what? Wait, what the fuck? Line 3 unexpected, semicolon got class. But I do semicolon. What the fuck do you mean? I saved it, right? Bro, what? That's how we did this. What the fuck? Is it retarded? No way, what the fuck? Oh, I'm stupid. Oh my god, I forgot again about this. Oh, an optional. Okay, perfect. So now we have some semantic errors. 122. So here, for example, value is gonna be optional. So instead of this thing, we can do a match, or I guess a case. Case the value of, and here we have value being none when we don't do anything, and value being some value. And in this case we have to do something like this. Suck. So in this case we print, here we have the value, so let's just replace it with v. Okay, so 127. Okay, semantic error 124 is that no v. We could do toString, but yeah, we get back some object, right? Because it's a sum. Wait, what? Yeah, it's a sum, right? So we could call value on it, or what? Or we could say v.value. So that's just the optional, so string object. That makes sense. But it won't work if I do this. Would be cool to have some kind of automatic casting. Oh, I don't re-implement toString though. But that's like whatever. So I would have to say here like another case. Let's do another case. That's why I didn't really like this optional, but I mean it's still better than ifs. So yeah, it's we have optional. Okay, so no, pretty decent, I would say. We have the ability to parse plus symbols and integers. So I guess next would be maybe like keywords. That's always fun. And other types of symbols, I would say. So yeah. let's see what happens if we pass in the other one. So well, at least we get it doesn't crash, right? Like that's pretty cool though. Interesting. Okay. I'm wondering why it's not showing the first character though. Did I make a whoopsie? Skip white spaces. Yeah, not really. I don't know why. Oh. Yeah, that's why. Okay, let me see how I handle the illegal. So even though I read a char, I took the char from the position. Okay. So see, it's like take the char from position. So I should probably just say buffer at or what? Subster position 1 maybe. So now it looks a bit better, I would say. So it's CLAA, yeah, it's class, token, see? Like you get all the characters that are important. So what we have to do is to make them not be illegal, basically. So that's the next step. So let's see if we are gonna be able to do that. It's gonna be int literal. So yeah, that's no, that's for the next time basically. So let's make a commit with these things. We are not gonna put the test, so yeah, just that. So compiler in compiler. So it's like what was that movie, Inception? It's a new level of, yeah. I mean, you know what, like I've tried so many languages, all of them are trash, and like that's why I'm just kidding, this one is the most trash one I've seen so far. Like, but I mean, it's fun to see problems like oh, I need a new type, I can just add it. Or like see, like why does Rust have this optional type? And I'm like, okay, now I get it, why it has it. Or like other features, you understand better why they are required, let's say, in other languages. So yeah, but yeah, for the next time we'll see if we can add more tokens, and after we have enough tokens I would just go to I don't know, maybe try to make a really small interpreter for like adding numbers, just to have something, and then continue with the compiler until the end or something. So yeah, so see you in the next one.